Well, good morning, my Algebros. Happy Veterans Day. Gonna go through this study guide so you have lots of time to get it early and prepare for the test that you'll have. For A Day will be on Thursday, for B Day will be on Friday. So this is our Chapter 4 study guide, Solutions. All right, on the first question it asks, actually the first two questions ask if these are functions and if they're linear. Well, the first question, we can see obviously that it's not going to be a linear function because it's not a straight line, right? But I can see that if I wanted to use my vertical line test, I could see that it is definitely a function because X does not repeat or cheat, right? What we mean by that is if I go skip down to here, you can see as I drag this across the line, the blue line only touches these lines in one place, right? These are all functions. These are all functions, right? But on number 6, which is not a function because X repeats, see how it touches it on all the places? It repeats. That's how this vertical line test works. Okay, just want to clarify that. And so let's take a look. Well, we know it is, yes, it's a function, but no, it's not a linear function because it's not a straight line, right? Not a straight line. Okay. Number 2, in order to check on a table, we need to see a constant change in both the X and Y values. And as I look at table 1 or table A, it goes up by 3, it goes up by 3 on the X values, and then it goes up by 2. I can see right now I can stop. I don't need to continue because there's not a constant change in both the X and Y values. The X values are not constant. The Y values are, but the X values aren't. And that's why it is not a linear function. It's a function because X is not repeating or cheating, but it's not linear. On letter B, we see that the X values are going up by 1 every time, so that's a function, and the X's are not repeating, and it's also linear. And the Y values also go up constantly. This happens to be by 2. So yes, this is going to be a linear function because there is a constant change in both X and Y values. Number 3, we're just seeing if these are positive, negative, 0, or undefined. This one is positive because we read from left to right. And as we do that, we see it's going up, which is positive. Number 4, also I gave an example, like as a fraction in an equation, y equals mx plus b, this m could possibly be like positive 1/2 or positive 3 or positive whatever. If the slope is positive, it has to be pointing upward. On number 4, this is a 0 slope because there's no slope. You can see the y is repeating on here, right? Well, the y is repeating. And that's okay. It's called the 0 slope. And an example of a fraction one would be if you have 0 divided by 2, because I can take nothing and divide it amongst people, right? I could take no cookies and give it to 2 people and give them nothing, right? On number 5, we see this is a negative slope because when we read it from left to right, it's pointing down. And an example of a fraction could be negative 2/1 or negative 3 or negative 1/2. These are all negative slopes. The value in front of the X is negative. All right, and number 6, as we talked about before, this is undefined because the X is repeating or cheating. And we can also see this would be if I took a number and divided it by 0. If I get a slope that is divided by 0, that is impossible. I cannot take 2 and divide it so that it goes to nothing. If you don't get this, take a piece of paper and try to divide it so that it disappears, and it just doesn't happen. That's why we call this undefined. You cannot divide by 0. All right, making a t-table to solve for our x and y intercepts. This is when an equation is in standard form, right? Standard form where we have, I'm just going to add this really quickly here. If I have ax, right, plus by equals c, a constant. We know that these are whole numbers and that they're in standard form. And we use standard form to solve for our x and y intercepts. If I want to solve for my y-intercept, then x must be 0. And I just substitute 0 in for x. And I can see it's going to cancel out the x value. And I simply divide by the b in front of the y, right, that -8. And I get that y is 3 when x is 0. It's the only time that y is 3, when x is 0. I solve for the x-intercepts when y is 0. So I substitute that into my equation, and it will eliminate the y values, and I simply divide by 6 to solve for my x-intercept, which is -4, when y is 0, right? It's the only time that x equals -4 is when y is 0. So we use this powerful way to solve for x and y intercepts in, say, a standard form equation in a word problem, like in number 8, where it says that a parking meter gives 15 minutes for a quarter and 3 minutes for a nickel, right? So if it's 15 for every quarter, that's how we get 15x, because x is represented in quarters. And if it's 3 minutes for every nickel and y is represented by the nickels, that's why we have 3y. And it's wondering how many would you need if you parked for 15 minutes, or if the constant, 45 minutes, or if the constant were 45, right? Okay. So I make my t-table and I see Joey only has nickels. That means he has no quarters. He has no quarters, right? So he does not have any x's. Then we use our standard equation and we substitute in 0 for the x, and we can find out for 45 minutes, which is our constant here. We see that he needs 15 nickels. That's what it's going to take because he doesn't have any quarters. Regina only has quarters, so she has no nickels. If she has no nickels, then we substitute 0 in for the nickel value, and we find out how many quarters she must have. And it turns out to be 3. She must have 3 quarters. And if you did the math, 3 quarters is 75 cents, and 15 nickels is also 75 cents. So they have the same value, just represented in different different coins. So there we have it. That's how you use standard form in a word problem. Number 9, we have this scenario moving over to slope, and we know slope is always rise over run, or y over x. So on our scenario here, Casey's casserole, we can see that it is rising 10 because it goes from 10 grams of fat to 20 grams of fat to this point. 10 over our run, which is 2, and we do the math. We get 5 over 1. What does that represent? Well, we know it's always y over x, so this is fat per serving, or 5 grams of fat for 1 serving. That's what this represents. Number 10, we're looking at the slope of the line here. We could see that we, again, rise over run. We're rising 4 and we're running 2. We could see it's going towards positive infinity, so it should be a positive slope. And we just simplify that fraction. 4 over 2 is 2. Our x-intercept happens to be -2 when -2 when y is 0, and our y-intercept when x is 0 is 4. And then when we write the equation of the line in slope-intercept form, right, y equals mx plus b, we substitute in our y-intercept, which is 4, and our slope, which is 2. All right, number 11. Now we're going to get to use all of our formulas that we've been using on this little sheet. And you will have this sheet color coordinated for the day of your test. Even if you're in the testing center, you will have one, so don't worry about that. I will make you a note card. You just need to know how to use it right. So here it's asking to use the slope formula. So obviously we're using that slope formula. And we have 2 points. So we have an x1 and a y1 and an x2 and a y2, simply saying that the first point is the 1s and the second point is the 2s. And we start with substituting into our formula, which says we have y2 minus y1 over x2 minus x1. That subtraction is always there, right? So when we take away a negative, that's obviously going to have to change to a positive. So we have 4 over negative 12, and we simplify that to be negative 1/3. On number 12, again, we follow the same thing. Check your work, see if you're substituting in correctly. You should have 4 minus a negative 2 over 5 minus 3, which gives you 6 over 2, which reduces to 3, right? On 13, 14, and 15, we're given a series of equations. On the first one, we see it's y equals negative 5. This is a zero slope equation. There's no x value. So you can see with y equals mx plus b, this value must have been 0 because it makes it disappear, right? It multiplies by 0. So there's only a b value because all of the v values are negative 5, or it's a zero slope because the y value is repeating. On 14, this is y equals mx plus b. Some people kind of forget, if there's a value in front of, if there's no value in front of x, there's at least a 1. So when we find our slope, we know it's going to be 1 over 1. We'll rise 1 and run 1. And 7 is our y-intercept. For 15, we see that there's no b value, or it's 0. And that just means this is a direct variation equation. Our slope is that value in front of x. Please do not include the x in there. It's just 6 over 5, and our y-intercept is 0, or it's a direct variation. All right, in number 16, 17, and 18, we're asked to graph these equations. The first is in y equals mx plus b. So we can identify our y-intercept as negative 2, and our slope is 5 over 3, or we're rising 5 and running 3 because this is a positive value. So they're going positive both ways. So I start at negative 2, I rise 5, I run 3, and I use a ruler and connect my dots across the entire graph. 17 is in standard form, so I think, maybe I'll just make my x and y intercepts and graph this way. But when I do this, when I check on the graph, I see that there's no 6 when I go across. I'm like, it doesn't fit on the graph. And I don't want to kind of estimate. I want to be exactly graphing. So I've got to go a different way and solve for y. If I solve for y, it will be in y equals mx plus b. We did this a ton on our project and in class. So I have to move the x value over to the other side and divide by 6. If I divide by 6, everything gets divided by 6. So I end up, if I have 2 over 6, that reduces to 1/3. Don't forget about that. I reduce that fraction, making it a little more simple to graph. My y-intercept is negative 2. I start there. I rise 1, and I run 3, and I draw my line. And you can see it would have hit that point of 6, right? That I really wanted to put on there, but the graph was just not the right size. All right, number 18, it's almost in y equals mx plus b. So rather than getting it in standard form and doing all that, I'm just going to divide everything by negative 4. And I get y equals negative 1/2 x minus 6. How did I get negative 1/2? Because negative 2 over 4 reduces to negative 1/2. Then I start with my y-intercept and I go, oh, I've got a problem. I can't go down on my slope. I have to apply my negative here. If I apply it here, I'd go off the graph. So instead, I want to apply this to down here. Apply it to the 2 instead. That means I can rise 1 and run -2, because you can't do a negative, that makes it become positive. So you have to apply it either to the 1 or to the 2, and in this case, it works out better to apply it to the 2. And you can see it is a negative line and it's a negative slope. Number 19 says y and x vary directly. What does that mean? It means that they are equivalent fractions, right? So there's no y-intercept when we're using this to graph. All we have to do is find the slope. But in this case, it's saying we have this point on the graph when x is 4, y is 14. What would y be when x is 10? And rather making an equation and then substituting and graphing and finding it, we can just use equivalent fractions because I know it's y over x. It has to have the same slope. When y is 14 and x is 4, that would be a point on the graph. I can find y when x equals 10 because of this property that we learned in chapter 1 called cross products. Now, this is not cross canceling. Please do not confuse it. This is cross products. And you see this only when there is an equal sign. This is equal, right? So they're equivalent fractions. And we solve here by doing cross products. So 4 times y, because products means to multiply, will equal to 14 times 10, which is 140. And then I simply can solve for y, isolating it by dividing by 4. And we can see that when x is 10, y would be 35, right? Number 20, we are going to write an equation. An equation is y equals mx plus b. That represents the total cost of a cab ride as a function. We know cost is always y. Right? Cost is always the y value, always y. So that's why we can say y equals, because we want to know for the cost. So the y equals something, the slope, or something per every x value. That's our slope, how much we're rising to the x value. And the y-intercept is the initial fee. So $5 is our initial fee. In this scenario with this cab drive, it charges $5 right off the bat, no matter how far you go. And then for every mile, it's $1.25, right? So per mile, the cost per mile is $1.25 per every time you do a mile, which is represented in the x's. So now we have our equation. We can solve for any cab ride for any amount of miles. When x has a certain value, we can solve for the y, or the cost. So if we go 16 miles times the per mile fee plus that initial cost. So 125 times 16 is $20 plus 5 is $25. So when x is 16, if we go 16 miles, then the cost would be $25. On 21, we are using our formula sheet to use the point slope form. And if you're given a point and a slope, you use the point slope form, right? And all it's asking us to do is to put it into the point slope form. We don't even need to solve. So we find that on our formula sheet. We identify our slope and our point, and we substitute in. The y1 is 6. The slope is 3/4. And the x1 is -2. And we could be done here, except we have a double negative. So we want to make sure that we fix the double negative and then rewrite it. So y minus 6 will equal 3/4 times x plus 2. And that's all we have to do for this question, is just put it in the correct form. Now that we know how to use the form and substitute into it, we can solve anytime we have a point and a slope. That is why it's called the point-slope form. You must solve this way. Please don't work with a tutor or Google some other way or AI, a different thing. Please do not do that. You need to learn point-slope form to prepare you for Algebra 2, but also to learn how to do things in the different way, right? So it's just part of learning. We want to become really confident with this. So we're given a point and a slope. So we use the point-slope form. My first step is I substitute in for my y1, which is -2. My slope is -5. And my x1 is -3, right? And I have to solve, right? I have to first substitute in. Sometimes I see people just write a point, giving it an x and a y and a slope, and they don't solve, and it just doesn't make sense. So please don't do things out of order. Do not make a bad assumption. Use the formula, trust the process, and substitute in, right? Just like if you're playing a sport, you substitute in for your position. You don't change up positions. You don't start making stuff up. You got to substitute in where your coach tells you to go. Substitute in, right? Then all you have to do is solve. Solve for y. That y at the beginning, that little purple y, right? So we get y plus 2 because we have a double negative. Then we distribute -5 to our parentheses, and we simply subtract 2. We get y equals -5x plus 13. It's excellent. Oops, I should have put a stop there. My bad. Let me just put a pause there. So check this out. You can always pause the video and go back as well, right? Slow it down. Then on number 23, I'm just going to clean off my board so I have more space to write and I don't want other things hanging out there. Number 2 gives us 2 points. We could use the point-slope form if we had a slope, but that's okay. We have a slope formula to find a slope, right? So we use our y2 minus y1 over x2 minus x1, and our first step on this one is to find a slope. We see the slope is going to be 2, right? Now we get to use the point-slope form because we have a point and we have 2 slopes to pick from. So if you choose point number 1, because you get to pick what point you want to pick. If you choose number 1, this is what happens. We put into our formula, point number 1, y minus y1, which is 4, equals our slope that we found is 2, times x minus 1, because our x1 is that, and we solve for y, just like we just did in the previous question. And we get our equation of our line is y equals 2x plus 2, right? Now, what if you decide to solve for point 2? You should get the same equation. Great way to check something if you're worried. But let's go ahead and try this one. So if I use the second point where x is 3 and y is 8, I substitute in for the positions using the same slope that we just solved for, and I distribute and solve. And you can see again, I get y equals 2x plus 2 because they have to be on the same line. It has to be the same. So it does not matter which one you pick. That's why it's an or. Pick this one or that one, and you'll get the same answer. Powerful, huh? All right, 24 is looking at, do we know the difference between parallel and perpendicular slopes? We just learned this last class as our last lesson. And we know that if it's a parallel line, it has to have the same slope. Parallel has 3 L's in it, reminding that there's the same letter 3 times. Please remember this is the same slope. So in this equation, the slope is 4. So what's the same as 4? Well, that would be 4. It's not that deep. It's 4 because it's the same, right? A perpendicular line would have to have the opposite reciprocal, perpendicular, many syllables, do many things to it. Opposite from positive turns to negative, and reciprocal is flip it over. So you take that 4 and put it over 1, and you flip it over. That's the reciprocal, right? From positive to negative and reciprocal, flip it over. So with this little powerful information, we can do 25 and 26, right? Because we are given a point and we're given a slope of a line. And it says, if we have this line and we graph this line of y equals negative 4x minus 12, we need to make a new line that would be parallel to this line. So anything parallel to this line would have the same slope. But the catch is this, and please don't miss this. The catch is it has to go through this point. It's not just any parallel line. It's a very specific parallel line that must go through this point. This is the tricky part of this question, right? So we can do this. If we have a point, which we do, 8, negative 2, and a slope for a parallel line will be the same slope, I can use my point slope form and substitute in to find out what this line would be. And I go ahead and I solve, doing a double negative, then distributing my negative 4 and solving for y. And I see the equation of this line that will be parallel to this line is going to be that goes through this point. That's the big catch. It has to go through that point, is this solution right here. Y equals negative 4x plus 30. The next question says, okay, now that you have a parallel line that goes to that point, we want a perpendicular that still goes through this point. It has to go through that point. This point is still the star, but it has to be perpendicular. So we know how to do this because we take the slope and we make it opposite reciprocal. If it's negative 4, then it has to become positive, right? It has to become a positive, and then we flip it over a positive 1/4. And we use the same point, right? Opposite reciprocal, same point. So now we use the same point, so we still have y minus the negative 2 equals this slope instead, times x minus 8. I distribute. I have to multiply a fraction. 1/4 times negative 8 will give me negative 8 over 4 or negative 2 when I simplify. And then I simply subtract 2 from both sides. And I have the perpendicular line that goes through this point. Okay? Now, if you're like, I'm skeptical, I'm not sure about this, I'm trying to trust you, Seamson, but I'm not sure if this all were to work out, right? You could technically take a sheet of graph paper and graph these out on your own. Now, I know this y-intercept over here is pretty big, so you're going to have to use a pretty big sheet of graph paper, but go for it. Graph them out, see if it actually works, okay? Talk to you next class. Have a great day.